Okay, the last thing to go over is problem solving with simultaneous equations. No one likes worded problems, so with a grindstone mentality, if you don't like it, that's what you focus on. The ultimate goal is to use maths in useful scenarios. Being able to deal with two variables opens up the possible scenarios compared to previous years. These below are some good steps to follow to solve problems with simultaneous equations. They're very similar to the worded problem steps that you've had before. Decide what the variables x and y represent. Often the question will tell you what they should be. Step 2, construct two equations from the question info connecting x and y. Solve simultaneous equations. How many different methods have you got? Graphing it, 1. Substitution, 2. Elimination, Friday afternoon, 3. The fastest way is usually going to be by elimination. Check the solutions with the original scenario if you have time and write your answer in sentence form. Please don't lose a mark because you got the right answer and then you didn't say, therefore, X is something in words. Answer in sentence form. So every year, people don't like, why can't I have a set of steps for every kind of worded problem? Worded problems are really variable. So step 2 can be difficult as there's not one way of converting info into equations. So how do you overcome that? You overcome that by practicing different scenarios. That text seems a bit small. I'll increase the size of the text. Now it's on the projector. It seems a bit smaller than it should be. I think that's better. That's your example. We'll have a go at that. I'll get some cheat sheet paper ready for you. If you are up to the example, have a think about the simultaneous equations you would use to represent. Come in, but it's recording, so just go through this way. Never mind. So example, 2 adult tickets and 3 children's tickets cost $45. 3 adult tickets and 4 children's tickets cost $64. Find the cost of each ticket type. Is the question telling you what to make X and Y?
Yes.
No, definitively no. Does it say you must make X, but you got the choice? No. So what could we make What could we make x equal to? X could be the...
Cost of each ticket.
Which one? Adult. Because it's the first thing that comes up. Y equals cost of children's. So what the hardest step of these is working out how the information gives us two separate equations. We have one scenario that costs $45 and we have a second scenario that costs $64. So what would my equation be for the 2 adult tickets and 3 children's ones?
2x plus 3y is equal to 45.
Good. Therefore, the second one would be...
Where x plus 4y.
And because of the information we use to construct this, are they simultaneous equations?
Yes.
Are they referring to the same x and y? What was the thing that I used to show that they were simultaneous? What was the thing that went over here? Was it a line or was it like a weird... Yep.
Hello, curly bracket.
Curly bracket. They're simultaneous now. I don't want to waste time drawing a Cartesian plane to do this graphically. Are any of them written with x or y as the subject? No. So elimination is usually the fastest one. Are any of them already the same size but opposite sign coefficients? No? So try to get the smaller ones the same. What's the smallest number that 3 and 2 both go into? 6. I had a question last week. I don't want to say the name, but it was from our student over there. Does the top one always have to be positive? No. The only goal is that the coefficients have to be the same size, opposite sign. So I'm going to, on purpose, times the top by -3. That's not what I showed you last week, but it doesn't matter. What matters is that you're going to get the same coefficient, different sign, times by +2. So what's this going to look like? Times by -3, -6x, -9y, I don't know my 45 times tables. 3 times 45, 135, but it's going to be -135. Bottom one's going to be 6x plus 8y, 64 times 2, is that 128? I think so.
Yeah.
It's one of those,
Yeah, it is.
it's like 7 times 6, I always check, just to be sure. Are they the same size, opposite sign in front of x now? Yes or no?
Yes.
Yep, so I can add vertically. If I've got -6x's and I add 6x's, you're going to have 0x's. If I've got -9y's and add 8y, you're going to have -1y. -135, 135 negative plus 128, -7. If -y is -7, what would y be? Any thoughts?
7.
Yep. If you don't like that explanation, what's the opposite of timesing by -1? Dividing by -1. Divide both sides by -1, you'll also get 7. Is that the solution? Or is there something I'm still looking for?
Put it in
I need to put it into the other one, and MLG Programmer move, put it into the easier looking one. 2 and 3 are smaller numbers than 3 and 4, so I'll put it in there. So 2 lots of x plus 3 lots of 7 equals 45. 2x plus 21 equals 45. 2x. Where's it going? 45, take 21, 24. So what's x going to be? 12. What was the last step of the steps? Am I done yet or am I going to lose a mark right now? I'm going to lose a mark. It's not in words. So you need to go there for the adult tickets cost 12, the children's tickets cost 7. That's it. I'll stop the recording so you can chat.